Core2 Summer 2015. So we just start by adding angles to the diagram. So it flies for 70 kilometres on a bearing of 110. That means this angle in here is 110 because a bearing must be measured from north. After picking up, the helicopter flies 80 kilometres on a bearing of 30, so I'm going to add a north in, and we have an angle of 30. So what we need to do is work out the angles that are actually in the triangle. And what we know is we have a U shape, so the two angles must add up to 180. So this angle is 70. So now I have a triangle with two sides and an angle, and I want to find out the third side, so I'm going to use the cosine rule. So d squared has to equal 70 squared plus 80 squared minus 2 times 70 times 80 cosine 70. So putting that into the calculator, d is 115.08, so that's 115 kilometres to 3 significant figures. Now I want to work out the angle, and I'm going to call that angle x, and this time I'm going to use the sine rule. So the sine of x over 70 has to equal, so that is the sine of the angle over the opposite side, has to equal the sine of the angle, so that's sine 70 over the opposite side, d, which is my answer to previous. You need to be careful here, you need to work to more than 3SF. So sine x equals 70 sine 70 divided by 115.08. So x equals 36.79. If I go back up to the diagram and draw on a north, I'm actually interested in this angle. We need to start working out what that angle will be now that we know what x is. We also had a north here, knew that this angle was 30, so using our u, we know that the whole angle here is 150, which means the bearing is the complete angle 360, take away 150, plus the x, which we showed was 36.79. So our angle is 210 plus 36.79, which gives us 247 degrees for a 3-figure bearing. Part B, we're dealing with radians, and we have two key formulas. The area of a sector is a half r squared theta, and arc length is r theta. So we're told that the area of the lawn is 2/3 the area of the total sector. So the total sector will have an area of a half times 6 squared times 1.2. So that is 21.6. The area of the lawn is 2/3, so 2/3 times 21.6, which is 14.4. So this area, 14.4, must be equal to 1/2 r squared and theta, which is 1.2. Dividing by 1.2, 12 equals 1/2 r squared. R squared is 24. R is the square root of 24. I'm going to give my answer as a third, 2√6. We're asked to find the perimeter of the flower bed. So if we start with the outer arc, the length of that will be 6 times 1.2. If we then look at the inner arc, it will be 2 root 6 times 1.2. And then we have these two sections here which will have the same length, and they are the difference between the two radiuses, so 6 minus 2 root 6. And the three significant figures, that gives us an answer of 15.3.